All right, guys, this is Miss Murphy. Um, I will be covering the first part of Unit 5, Lesson 5.1. So, this is about multiply and division. So, if you were in my class, in class on Friday, you probably already have this, so you can skip this video and move on to video 2. If you were in Miss Melby's class, I don't know exactly where y'all ended up, so this will cover multiplying and dividing exponents. All right, the next video will cover power rule. So, if we look at page 1, first off, just a general um, vocab review. So remember, when it comes to what the different parts of exponents and what makes them up, this 2 right here would be known as the coefficient. The x is known as our base. And the 5 is our actual exponent. So just to give some definitions, the base is always a value, so that can be either a variable or a number being raised to a power. The exponent is the power or number of times you multiply the base by itself. So for example, if you did 2 squared, you do 2 times 2. 2 cubed, 2 times 2 times 2. And the coefficient is the number. It's always going to be a number being multiplied to the base. So the exponent only applies to the base itself. If there's a coefficient in front of it, it doesn't necessarily it doesn't go with the coefficient. So for example, this raised to the 5th power, we would not also raise to the 5th power. It would only be raised to the x. Now, what's the difference between x squared and 2x? Well, if you remember, x squared is equal to x times x, whereas 2x is equal to 2 times x. So 2 very different things, because for example, if you think about it, 9 squared and 2 times 9 are 2 very different numbers, where 9 squared is 81, because that's 9 times 9, and 2 times 9 is 18. Again, 2 very different numbers. So exponents happen as a result of multiplying a value to itself multiple times. All right, which this is all review for you guys. You should already know kind of what an exponent does. So if we look at 5/3, if we wanted to expand it, we could rewrite this as 5 times 5 times 5. So 5 multiplied to itself 3 times, which 5 times 5 is 25, times another 5 is 125. Then we have x cubed times x to the 5th. So they have the exact same base, which is x. So if I do x cubed, if I write it out, it'd be x times x times x. That part's x cubed. And then times another 5 x's, which will represent the x to the 5th. Now, if you count the number of x's, there's actually 8 of them. So this is actually x to the 8th. Thus, what happens to 2 expressions that have the same base and the expressions are multiplied? Well, you would actually end up adding the exponents. So the exponent rule for multiplying power. So if you have x to the m times x to the n, this is the same thing as x raised to the m plus n. All right, so let's look at some examples down here. So example C. So you have 7x squared times 2x cubed. Now be very careful because 7 and 2 are considered coefficients, not bases, whereas the x's are your actual bases. So some people automatically add the 7 and 2 because they just get in the habit of the exponent rule. They don't think that the 7 and 2 are coefficients anymore. They think of them as exponents. So in reality, this is the exact same as 7 times 2 times x squared times x cubed. So you would multiply the 7 and 2 like normal. So 7 times 2 is 14, and then we get x raised to the 2 plus 3. So this would be 14x to the 5th. Now 10 cubed, that's just 10 multiplied by itself 3 times. 10 squared is 100, so multiply 100 by another 10, and that will give you 1,000. And then x to the 5th times x to the 4th, that'd be x to the 5 plus 4, which is x to the 9th. So we're going to do a couple more examples together. So if I look at number 1 in the class examples. First off, number 1, the 2's in this case are not actually coefficients, they are bases because they're being raised to a specific power. So we're not going to multiply the bases. So you never multiply the bases. So we're not going to do 2 times 2 and get 4. We're going to keep the base as it is, which is 2. And we're going to add the exponents like normal. So that would be 2 to the 7th, which you can put that in your calculator, but it is 128. Now, number 2, if there's no exponent, all right, we're still doing same bases because both are 8. If there's no exponent, the automatic exponent is 1. This would be 8 to the 1 plus 3, which is 8 to the 4th. All right. And you can evaluate that if you want, but I'm just going to leave it as 8 to the 4th for right now. Now, number 5, a little bit different. So, even though we have 3 to the 4th, if you notice, they are not 3 to the 4th is not the same base as the x's. So we can't do 4 plus 3 plus 5. The only thing we can do is evaluate 3 to the 4th, which is 81, and then add the 2 exponents. So I would add these two together. So that would give me x to the 8th. So remember, you can only combine exponents with the same base. All right, so we're going to do a couple more, and then we'll move on to division. So number 10, we have 3 different coefficients. So 4, -5, and -3. And we're going to multiply all 3 of those numbers together. So 4 times -5 is -20, times -3 is positive 60. Then we're going to look at the bases that are f. We're going to add them together. So 9 plus 6, that'll be f to the 15th. And then lastly, we'll look at the h's. So 3 plus 2, that is 5. Now, the last one we're going to do for multiplication is this challenge problem, so number 12. So your coefficients, there's a 3, but there's also a -1. So if you ever see a negative sign on the outside, it is denoting a -1. So we're technically multiplying 3 to -1 together, which is -3. Then we look for x's. There's nothing to combine it, so we just bring it down, x to the a power. Our y's, so we'd have y. And remember, you just add these two exponents. So we would just write it as an expression of b plus f. And then your z's, again, you would write as an expression as c plus g. So even if we don't have the numbers, you can always still write the expressions because we know what those rules are. So that's multiplying exponents. Now let's look at dividing them. So first off, if you look at the expanded form of division, it kind of makes a lot more sense of what's going on. So if I expand x to the 9th over x to the 7th, that means I'm going to have 9x's on top. So 9x is in my numerator. 8, 9, all over 7x is on the bottom. 4, 5, 6, 7. Now, remember, if you have something on the top and the same thing on the bottom, and you're being dividing. So it's the same value in the numerator and the denominator. X divided by x is just 1. And remember, 1 multiplied to anything is just itself. So essentially, this cancels out. So from there, it's 1 to 1. So this 2x's cancel out, these two cancel, these two, these two, these two, and these two. You're just pairing them up. And then whatever's left over is your answer. So there's 2x's left over, so that's going to be x squared. We can do the same thing for letter B. So we're going to write out 3 or 2 3 times, and then 2 8 times. And then we're going to pair them off. So I have one pair here, one pair here, one pair here, and I'm left with 5 2's on the bottom. Now, since it's in the denominator, we're going to keep it in the denominator. And since there's nothing left in the numerator, we're going to put it over 1. Or 1 and then with the 2 to the 5th at the bottom in the denominator. So if I evaluate the 2 to the 5th, this will be 1 over 32. Now, lastly, we have letter C. So letter C would look like this. So 2's 3 times, 3 x's, and 4 y's, all over singular 2, a singular x, 2 y's, and 1 z. And then I would match them up. There's only one pair of 2's, so I'm left with 2 2's left. There's only one pair of x's, so I'm left with 2 x's left. There's 2 pairs of y's, so I'm left with 2 y's left. And there's nothing to cross out for z. So, given what I have left, and remember, you want to keep them in the same place that they are currently, this would be 2 squared, x squared, y squared, all over a singular z. And we can take it a step further and evaluate the 2 squared. So this would be 4 x squared, y squared, all over z. Now, if you haven't noticed already, there is a trick for dividing exponents, and that is you would subtract them. So you would subtract the exponents of like bases. So if you have x to the m over x to the n, it would be x to the m minus n. Now, a little trick that I like to do, just so I know automatically where it will go and I don't have to mess around with negative exponents, which you guys should know about negative exponents from last year, but just so you don't really have to deal with them, I always do big minus small, and I place whatever I get, so whatever my answer is, back in the spot of the big. So wherever my larger exponent was, if it was in the numerator, I would place my answer back in the numerator. If it was in the denominator, I place it back into the denominator. So let's do a couple examples and you'll see what I mean. So if I look at the next page, I have 8 a to the 8th over 8 cubed. So if I do big minus small, 8's bigger. So I have a to the 8 minus 3. Well, 8 minus 3 is 5, so this would be a to the 5th. And since it's in the numerator, the 8 is, I'll keep it in the numerator. So that would be a to the 5th over 1 which is still a to the fifth. Now, if we look at 16, I have x to the fourth over x to the 10th. So I'm still going to do big minus small. So I'm going to do x to the 10 minus 4, and that'll give me x to the 6. Now, since the 10 was in the denominator, and it's the bigger exponent, I'm going to move the x to the 6 to the denominator. I'm going to keep it in the denominator. But remember, that means that the x to the fourth, because we took away all 4 of those x's, are gone. So that would leave me with nothing but a 1 in the numerator. It doesn't just go away. So this would be 1 over x to the 6. If I keep going, so this 12 right here, it's a coefficient, but there's nothing in the denominator but 1, an unspoken 1, so we just leave 12 in the numerator. We then subtract our g's, and since the 8's bigger, it's going to go in the numerator. So if I do g to the 8 minus 3, this will give me g to the 5th, and it will stay in the numerator, so this will be 12 times g to the 5th. Then I do my h's, so 5 and 4, 5 is bigger. So I have h to the 5 minus 4, which is h to the first, or just h. And that'll stay in my denominator because that's where my bigger exponent is. So this will be my answer. For this next one, something to be careful about is if you have two coefficients, one in the numerator, one in the denominator, you're essentially just simplifying that fraction. So this would be 4 over 8, which simplifies to 1/2. So we would start this as 1 over 2. Then we would subtract p to the 11th minus 6, which would give me p to the 5th. And since the 11's in the numerator, I'm going to put the p to the 5th back in the numerator. To clean it up a little bit, I'm just going to rewrite it just without the 1 because it's unspoken. So p to the 5th over 2. Last example for dividing. So again, we got negative 2 over 10, so that'll simplify down to negative 1 over 5. X's, it's 2 minus 1, so 2 minus 1 is just 1, and since 2 is in the denominator, we put singular x in the denominator. There's no other y's besides what's in the numerator, so we keep y cubed. And then z to the first and z to the 5th, we do 5 minus 1 because bigger minus smaller. That'll give us z to the 4th, and since the bigger exponent's in the denominator, that's where we keep it. So if I clean this up a little more, it'll be negative y cubed over 5x z to the 4th. Now, last thing to note, these are a couple of powers with numerical bases that you should get used to knowing off the top of your head. Now, you can always double check in a calculator later, but I'm just going to tell you what they are. So 2 to the 2nd is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 4 squared is 16, 4 cubed is 64, 4 to the 4th is 256, 5 squared is 25, 5 cubed is 125, 6 squared is 36, 6 cubed is 216, 10 squared is 100, 10 cubed is 1,000, 10 to the 4th is 10,000, 10 to the 5th is 100,000, and 10 to the 6th is 1,000,000. So tens are easy because all you do is just for every power you go up, you add another 0 at the end. All right, and that is all for multiplying and dividing. exponents, head on over to the second video to hear about the power rule.